Well, this is very exciting. We're here at King's College London to see the launch of our students' experiments into space. So here's the front page of the NASA website showing the rocket which is going to take our experiments into space.
So yeah, we're really excited. We're hoping the slime mold goes in three-dimensional form, and it is surreal. It's happening right now.
Yeah, I can't believe it.
Yeah, really excited. I would just like to thank everyone at King's College London and Mission Discovery for making this possible.
Yeah.
It's been an amazing experience.
Well, I'm glad to say that we are joined by Siobhan Yanakalendran and Deanna Middleton, who were among the first British students to have their experiments sent onto the International Space Station this week, and Chris Barber is Director of the International Space School Education Trust, who helps make it all happen. Very good morning to you.
Hi.
Well, Siobhan, how exciting.
It's amazing. It's really, really surreal, and we did not expect it at all. So yeah, we have to enjoy this, I guess. My team, we were Team Daffodils. Our project is based on slime mold. It's really fascinating organism, kind of. It's taken scientists and experts by storm, but in the way that we think of intelligence, and the fact that it's a really simple plant or organism that can retain memory in the way that if you were to put it in a maze and then say a petri dish, it would find the way to the source of food and kind of remember that trail and make one efficient pathway.
And how does it help sending it into space?
If we sent it in, we would to find out how it works or reacts in space. We can utilize that to see what we can use, further uses, whether in space or on Earth.
My name's Julie Keeble. I've spent the last 18 months working with the winning teams from 2012 Mission Discovery on their experiments, getting them ready to go into space. Firstly, I'd like to say what a massive privilege it's been to work with students who have come from secondary schools on such amazing projects that many a scientist couldn't have come up with.
Absolutely delighted to be here for the launch of the first set of experiments back in the summer of 2012 when these experiments were designed. We hoped that we would launch them into space, and it's fantastic that after all the hard work that lots of people have put in, the children have had some fantastic ideas, the experiments have been refined, and now we're here with a few minutes to go before take-off. It's fantastically exciting.
12 British students involved in all in sending these two things up into space, and presumably you're hoping that they will stay, many of them, in the space project, so to speak, because we're looking for tens of thousands more people to get involved in the British space industry.
Well, that's right, but we also, our main hope is that the young people that come on the project, not just those whose experiments are selected, but they come away more capable and believing in themselves and think that, they meet astronauts, they work with astronauts, they work at King's College with some great and world-renowned scientists, and that they remember that they were just ordinary schoolboys and girls like them, and that they go away believing that they can do something. And ideally, if they want to do something in maths and science, which we need, and ideally if they think about coming into our growing space industry.
The students have told us for the last couple of years that they've built confidence, and also they feel that it's something that they've built their self-belief. They can see themselves by meeting these really fantastic and inspirational people. Also, it's really good for them to be able to build their scientific knowledge. Again, they've told us for the last couple of years that they've really boosted their scientific knowledge on space exploration and the benefits to the human body as well as to the planet Earth. So we're really, really proud to be part of Mission Discovery.
And I was a mentor on the Mission Discovery programme. So it was my job just to support the students as they were coming up with their idea for an experiment and just to help them develop what they were doing. So it's been incredible to see them come from just putting those ideas on paper to actually seeing it now going up into space to actually be on the space station.
Little did I know that it would develop into something that's actually going up there. I thought it was going to be handed over to boffins in Houston who were going to organise the lab preparation, but when we suddenly had a call to go to Houston to set it up for the students, it was a bit of a surprise. And what you know now, here it is on the spaceship waiting to be launched. So I still can't quite believe it. And I've always been very interested in science and space. Always thought I'd be too small to be an astronaut, but this is the next best thing.
It's been brilliant. I think all of us have learned huge amounts about how experiments are sent to space, what's possible in space, and everyone has made such an effort to make sure that today these experiments are actually on the rocket behind us being sent to the International Space Station.
5, 4, 3, 2, 1. We have ignition. We have liftoff of the Antares vehicle for the Orb 1 mission from the Wilds Flight Facility, delivering Cygnus on its first commercial resupply service to the ISS.
And with that, at 7:05 a.m. Central Time, we will call the installation of the Orbital Sciences Cygnus to the International Space Station complete. Second stage capture has been wrapped up by the crew of Expedition 38, so Cygnus now officially installed on the International Space Station at 7:05 a.m. Central Time. The two spacecraft 260 miles above Earth, just to the southeast of Australia and Tasmania.
Houston Space Ground 2 for SSRMS Lee Snare cable imagery.
Bad on 2, Rick.
I took a series of about six sets of photographs for each of the 3 snares.
Can't wait for the results, what happens and what it actually does. Yeah, thanks.